Algebraic fractions. Always factorise first. Before you do anything with algebraic fractions, always factorise first. The first thing you do is factorise. Then the other main rule is this, a bit hard to write in words so I didn't, only cancel parentheses, not bits of them. People love to cancel. Oh, there's next, there's next. Can't do that. Got to be complete grouped terms. So let's start off. Well, this one here, obviously we don't factorise because there's only one term on top and bottom. So we're looking for things that will cancel, and we end up with just 2a squared on 3bc. But now we have this one. Ooh, so what's the first thing I'm going to do? Well, factorise is the correct answer. Geez, maybe I didn't stress that enough before. Always factorise first. The first thing you do is factorise. That's first thing. So the first one, which one would you factorise first? Actually, the top or the bottom? Which one are you going for? No, but you obviously got to do it in a particular order.
The top one.
Really? I would have done the bottom first. Because it's just a common factor of 2a.
Well, the top is a. Wow.
Yeah, but it's also p squared minus q squared.
Oh, mate.
So then, yeah, p minus q, p plus q. Aha.
Oh.
So now the p minus q's will cancel. That's what I mean by complete parentheses. And the a's will cancel, leaving us with just p plus q on 2. Okay. Multiplication. Of course, when we multiply fractions, before we can multiply fractions, what's the first thing we do?
Factorise.
Good. Someone's doing it. Very well. Factorise. Always factorise first. Okay, well, the x plus 1 and the 3x plus 1, that makes sense. We'll just put grouping symbols around them. Which one did I now go for, you reckon?
Top left. Top left.
Yeah, I reckon. Yeah, difference of 2 squares. Yep. Now, so in fact, everything cancels, leaving us with
1.
Good. I was hoping no one would say nothing because you've cancelled everything. Yes, it's 1. Uh-oh! Division. Before we can do multiplication, what do we do with algebraic fractions? Before we can do that division.
Factorise. Good.
Always factorise first. I was wondering if anyone was going to say, oh, you turn the second one upside down. No, you always factorise first. But I'm actually going to do the two things in one. So I'm going to turn it upside down because we don't divide fractions. Multiplication and division are, in fact, the exact same thing. It's just you're multiplying by a reciprocal, that's all. Okay, which one would I have gone for first? Yeah, it looks like it, because it's just a common factor, is it? Yeah. Now, the next one, well, a minus 2b I reckon is going to be a factor anyway. And looking at it even closer, it looks like it's a perfect square, isn't it? Yeah, it's a minus 2b all squared. So, now we can cancel to our heart's content, and we end up with 1 on 2a, a minus 2b. That's nice with multiplication and division, because of course we can just do that. Unfortunately, subtraction and addition we can't. So before you can add and subtract fractions, what do you have to do? No,
Factorise.
you always factorise first. Gotcha. All right. So we factorise it first. Now, here's how I deal with algebraic fractions. We've got to get a common denominator, as you said. There it is. What do? I say to myself, if it's not there, put it down. So I read across, I go, A. Oh, it's not there. Put it down. Because there's nothing there yet. A minus 1. Oh, it's not there. I'll put it down. A. Oh, it's already there. Don't have to worry. A plus 1. It's not there. I'll put it down. That becomes my simplest common denominator. Yes, you could have had a squared. It just means there'll be some cancelling that'll end up happening later on. But you get something simpler. So if it's not there, put it down. Now, the next step then is we compare and simply ask ourselves, what's different? That's what we'll end up multiplying the numerator by. The first one, it was a minus 1. It's now a minus 1, a plus 1. What's different? A plus 1. That's what I multiply the top by, a plus 1 squared. Minus, it was a plus 1. What's different? The a minus 1. So it's minus a minus 1 squared. Now, I think if I remember correctly, I did this the long way now. But of course, when you have got two perfect squares added together or subtracted, life is very easy if the numbers are actually the same. Because I'm going to get a perfect square here and subtract a perfect square. the squares will cancel. And I should be left with 4 times the product. Because the first one will be 2ab, the second one will be minus 2ab, so minus minus becomes a plus. So you can get that answer real quick. I went the long way, expand the whole thing out, but sure enough, there it is, 4 times the product. So if you pick up on the pattern, you can save yourself some time. What else have we got to do there? The a's will cancel, and there's our answer. Ooh, 3 fractions. Ooh, make it tricky. Well, what have I got to do here? Nicely, they've already factorised the first couple for us, but they haven't factorised the second, or third, sorry. So let's factorise that. Create a denominator. If it's not there, put it down. X plus y squared, not there, put it down. X minus y squared, not there, put it down. X plus y, well it's there because of the x plus y squared. You always have the highest power. So x plus y squared's the highest power. That's the one I want. X minus y squared, not there, put it down. What's different? It was x plus y squared. It's now x minus y squared, so x minus y squared, we multiply the 1 by. Plus, what's different? X plus y squared. Minus 2 times what's different? Now, again, we've got some patterns happening here. Perfect square plus perfect square. So now it's a plus. That should leave me with 2x squared, 2y squared. But now I'm going to subtract 2 times the difference of 2 squares, which will get me another 2x squared and a 2y squared. It's minus. What should I end up with? If I've done that right in my head, that'll be 4y squared.
Yeah.
Let's see. If you expand the whole thing out, there it is. Yeah, 4y squared we end up with there as our answer. Okay, there's the algebraic fractions.